Being a student of soil science, let me kickstart my talk with the saying, there can be no life without soil and no soil without life. They have evolved together. I am Kalaiselvi, pursuing my master's research at TNAU Coimbatore. I'm glad to pitch my subject matter on phosphorus dynamics under manure and inorganic fertilizer application, which falls on the theme plant science and crop production. Plants are everywhere, literally everywhere. When I say this, I mean they can grow anywhere from soil to the hilltop. We claim plants to be exclusively independent, which do not require us for its survival, unlike we do. The practice of agriculture recruits the process of domesticating plants for the progression of human civilization, starting from hunting, next to pastoral, then to crop culture, and ultimately to trade till date. We, the humankind, started to see agriculture as an art for embracing it, as a science for nurturing it, and in the end as a business for exploiting it. It was until Justice von Liebig, the father of agricultural chemistry, the world was not knowing that the growth of plant depends on the amount of mineral substances available in the soil, which led the researchers to explore the various range of nutrient elements essential for plant growth. In the present agricultural scenario, food grain production has doubled worldwide and trebled in India since mid-60s due to the introduction of green revolution with massive application of science and technology. However, recently a noticeable decline in productivity of many intensively cultivated areas have been observed. Hence, with the advent of green revolution, which triggered all types of resource management to meet the requirements of high yielding and potentially responsive crop varieties, India became a major importer of phosphorus fertilizer owing to its production of 150 tons every year. Hence, there a need arose to provide the database information on changes in soil fertility and the intensive farming for deciding agricultural policy. Thus, the role came that this Indian Council of Agricultural Research, in collaboration with state agricultural universities, initiated All India Coordinated Research Project on Long-Term Fertilizer Experiments, that is LTFE, in 1972 in major agroclimatic zones of the country, including Tamil Nadu Agricultural University, Coimbatore. Now the question may arise, why LTFE? Hence, in cropping, continuous cropping systems, a detailed investigation was contemplated to evaluate the long-term effects of fertilization on rhizosphere profiling with reference to pH dynamics, from which phosphorus dynamics and the manure and inorganic fertilizer application was taken as a part to present here. The objective of my study was to record the effect of inorganic and integrated nutrient management on the changes in the available phosphorus status in the rhizosphere and non-rhizosphere soil during the cropping period in maize. To address the question, why phosphorus is taken for the study, it has been rightly regarded as a key to human hunger because of its pivotal role in normal growth of the plants. It stimulates the early root development, and it also helps in the seed formation, provides strength to the straw, and hastens the crop maturity. Similarly, with increasing demand of agricultural production, and as in the global peak production, the phosphorus is receiving more attention as a non-renewable resource as well. One of the unique characteristics of phosphorus is its low availability due to slow diffusion and high fixation in soil, which makes it a major limiting factor for crop growth. As the availability of soil phosphorus is extremely complex, a holistic understanding of phosphorus dynamics and transformation among various phosphorus pools in soil system needs to be systematically evaluated for optimizing the P management. With regard to experimental details, the field experiment was conducted in the field of number 36 of the Eastern Block in TNAU Coimbatore. There were 10 treatments which were replicated thrice in randomized block designs, namely the treatment 1 is 50% of the NPK, and treatment 2 is 100% NPK, treatment 3 is 150% NPK, treatment 4, which includes 100% NPK plus hand weeding, and treatment 5, which includes 100% NPK plus zinc sulfate, and T6 is 100% NP, and T7 is 100% nitrogen alone, and T8 is 100% NPK plus FYM, and T9 is 100% NPK without sulfur, and T10 is absolute control. As I have previously answered why phosphorus is very important, why we have taken the study of phosphorus. Now coming to the imposition of various treatments resulted in a highly significant variation in the rhizosphere and non-rhizosphere available P. In general, among the stages, a gradual and steady decline in available phosphorus status in the rhizosphere and non-rhizosphere soil from the knee-high stage to the harvest was noticed in all the treatments during the entire cropping period of the maize. Among the different treatments, irrespective of any stages, the treatment which received FOM in addition to 100% NPK recorded significantly higher availability in the non-rhizosphere region when compared to that of the rhizosphere region. It was followed by the T3, which ultimately received 150% of NPK. Significantly, lower available phosphorus was recorded in the control in all the stages, irrespective of the growth period. A control recorded the lower available phosphorus. Now, coming to the discussion part, increasing rates of NPK application from 50 to 150% resulted in a higher level of availability. They were found on par with each other. Similarly, the presence or absence of K did not significantly influence any available phosphorus status. Withdrawal of phosphorus drastically reduced the available phosphorus status, which was on par with control at the harvest stage. Now, the reason for high availability due to FOM application may be quoted as the influence of manures in increasing the lability through the complexation of cations, which are responsible for the fixation of P. The enhanced levels of available P due to the conjoint use of manure and fertilizer promoted the recycling of nutrients and transformation of added nutrients into different labile pools. Further, the present investigation stresses the vital importance of including organic manure in the fertilizer schedule for enhancing the soil yield, maintaining the soil fertility in order to sustain the soil productivity over a long run. Coming to the future thrust of the study, unlike air and water, we do not have definite key soil quality attributes for assessing the soil quality. Identification of soil indicators sensitive to management practices and responsible for sustainability. Secondly, assessment of soil quality index at the different management practice and cropping system. Finally, investigation on effect of long-term use of organic and inorganic fertilizers on microbial community in soil through metagenomics for improving the soil quality and environment. May I conclude by saying, a nation that destroys its soil destroys itself. Thank you.